Okay, so we're going to go over the remaining examples from how to write equations with ellipses. So the first examples, remember, are the ones where they're going to give us a vertex and a co-vertex, and we have to use those values to fill in one of the equations. So remember that wherever the values are for the vertex, that's the major axis. So since there's an x value here, this is going to, remember, this is the a value and this is the b value, but that means that this is going to be a horizontal axis. Okay, that means that the vertices are going to be on the horizontal axis, and the co-vertices are going to be on the vertical axis. So x-axis and y-axis, which means it's going to look something like this. Okay, a little bit elongated. Okay, so that clearly means that if you remember the two equations, we talked about how with the two equations, a squared, if it is under x squared, that is the one with the horizontal axis. Okay, so it's going to be this equation here that we're going to use. So we're going to take that a value of -4 and we're going to square it, which gives us 16. And then we're going to take our b value, which is 1, and square it, which is going to give us 1. So these are the two values we're going to plug in for the a squared and the b squared. So the a squared is going to be 16. The b squared is going to be 1. And there's our equation. Okay, so that was pretty easy. All right, so then we looked at a second type of problem in which we have a height and a width, and depending upon which one was the greater one determined which way our axis was going to go. So if you look at the second one here, the height is only 10 feet and the width is 20. So if the width is longer, then it's going to be another example of a horizontal axis. Okay, a vertical would have a taller height. Okay, so that gives you, a reference point for figuring out which way to go. So we're going to use that same equation that we did up here. So I'll go ahead and move it down there just so we have it near us. All right, so that's what we're going to be using. So remember though, the height and the width are the entire length, meaning that if this was our ellipses, okay, it's the entire width from one vertice to the other vertice, so it passes through the center. Well, our a and b values are only supposed to be half of the distance from one vertice to the center squared. So we have to half each one of these. So the height, which is in this case going to be our b value, okay, because remember the co-vertices are on the vertical axis. That's going to be a 5, so I would square 5, because half of 10 is 5, and that would give me 25. And then our width is our a, and that's going to be half of 20, which is 10. So when I square 10, I get 100. Okay, and then I just have to remember that those have to be plugged into the formula. Okay, so remember that the a is going to be the larger number. So it's going to be here, there's 100, and then the b value is going to go underneath the y. So there is the equation for an ellipses that has a height of 10 and a width of 20. Okay, and then our last one is the hardest one because we have to use that Pythagorean theorem equation that we talked about. Let me go ahead and put our two equations down here so that way you can see and choose which one it is. Okay, so in the last example, remember a foci is a c value, which really does us no good in terms of writing the equation because the equation doesn't have a c value in it. The equation has a b and an a value. So the c is only there and only useful to us in helping us with the equation so we can find a and b. Okay? So the co-vertices, remember co-vertices always have a b value. Okay, so we're going to be using those to help us, but we're going to have to use an equation. Let's look though. Remember that the foci are always on the same axis as the vertices. Well, since the foci have an x value, that means this is also going to be a horizontal axis, so it's going to be this one again, okay? Just so happens that all three of our examples have been the same one. So I know that when I'm all done, my a squared and b squared are going to be in these locations. So I do have to be able to figure this out, though. I can use the b value. The b value is a 2. So 2 squared is 4. So at least know that b is going to get plugged in here for b squared, okay? But I do have to find out the a value, and the only way to find the a value is to use our little formula. C squared equals a squared minus b squared. Now remember, the hyperbola equation is the regular Pythagorean theorem, okay? So they're two different equations, but they're variations of the same thing. Okay, so C is 4, so 4 squared. A is what I'm finding, and B squared we already determined was 4. So this is 16. A squared minus 4, so add 4 to both sides. So when I do that, I'm going to get that a squared equals 20. So there's the values, and now I can just plug them into the formula. So the formula is going to be this one. Let me move this back up. So for the formula, I'm going to get x squared, b squared we determined was 4. So that's going to go second. The a squared is 20, so 20 goes first. And the b squared is 4. And this is my equation. So that helps you fill in the rest of your notes for that, and I'll make the other videos as well.